Okay, so difference between simple interest and compound interest. If you're making an investment or you're putting money into a savings account, gentlemen, I'm not speaking over you. Hi, it's my class. Hi, it's my class. When we're looking at making investments or savings, or if you're looking at making a loan for like a mortgage or anything like that, a lot of the things that you're going to talk about is compounding period, interest rates and payout rates and all those kinds of wonderful things. So the difference between a compounding interest and a simple interest is this. If you put $100 into, let's just call it investment for now, okay, and the investment interest rate is 10%. When you are collecting simple interest, they calculate the interest based on what you put into the bank. So if I put in $100 at 10%, what's my interest? $10, right? So every time my interest is paid out, I get $10 added to my total. So every time it gets paid out, it goes 100, 110, 120, 130, 140. It goes up by 10 based on my initial investment. If you put in your money into a compounding investment, then it is recalculated every time it's paid out. So initially I have $100, 10% is 110. But then it recalculates the next time they pay you out of 10% of $110. So my next payment is $121.10. Then they recalculate it again based on what's currently in the account. Then I end up with 133.10, I think. 133 or whatever the cents is. It grows and grows and grows incrementally over time because the compound interest is reevaluated at the end of a payout period. Okay, so the compounding period is what we're going to be calling it, right? The end at which it's recalculated and the buildup of that interest in your account. So if you're doing investments, if you're doing savings, you want to make sure you're finding investments and savings where the interest that they give you is compounded so that it's building quicker than if it was not compounded. It's growing exponentially, right? Whereas the opposite is true when you want to look at loans. When you're looking at borrowing money from somebody that you have to pay back, it's always better to find a loan that you get simple interest calculated because then the amount you owe back is incrementally less than the amount that if it was compounded. Now, I'm sorry to say you live in a world where simple interest doesn't exist on loans unless it's from like a family member maybe or a private loan. I don't really know. Typically, the way that banks make money is by collecting interest from people with loans. But banks lose money when they are taking your money and investing it and have to pay you out in interest for your investments. So typically what happens is they'll do compound interest for both, but your compounding period will be different. For example, when you invest your money, they're going to pay you out.
Any members of the track and field team or anybody from PE leadership that's helping with track and field, can you please make your way down to the snack shack? Any members of the track and field team or any PE leadership that's helping with track and field down to the snack shack, please. Thank you.
If that applies to you, go ahead. And if it doesn't, we're going to keep going. So they're going to offer you investment and savings opportunities where the compounding period is something like annually or quarterly. Quarterly means that you get paid 4 times a month, 4 times a year, or monthly, semi-monthly or semi-annually, something like that. It's usually a longer period of time. However, when you borrow money, depending on the kind of loan that you're taking out, they're going to choose a compounding period that's more often. So sometimes you'll get a loan that's compounded monthly, sometimes weekly, sometimes it will be daily. For example, your credit cards are compounded daily. Your line of credit, if once you get older and have assets and things like this, when you get a line of credit, the interest is compounded daily, means every day they're recalculating the interest rate so that they're making more money on you when you borrow money and aren't paying you out as often when you invest money. That's how the banks make their money, right? So it was very interesting to pay attention to compounding period and your interest rate. So all that to say, we are looking at applications today. And applications is basically all word problems, and exponential functions are used in all kinds of areas of life. Finances is one example. When you go into physics and chemistry, we talk about nuclear things and isotopes and half-lives of decaying radioactive elements. That part is all exponential calculations. When you're looking at the pH scale in chemistry, that's all exponential equations. When you're looking at growth of populations, whether it's bacteria or people, or the decay rates of things, again, such as bacteria or viral, or if you're modeling the spread of disease and things in biology, all of that is related to exponential functions. Okay, so this applies to a very, very wide range of real world examples, and we're going to do 2 or 3 today. So we're starting off with finances, and one of the annoying things with compound interest is, unless you know the formula for it, which is written here, my friends in the back, unless you know the formula, the only way to know how much money is in your bank and when you're compounding your interest is to do it step by step, which is annoying, which we're not going to do because we're mathematicians and we are very, very smart. We have an equation that tells us how to put the formula and the pieces together in order to find what is our final investment amount. Hi. Yes. Do you need change? Okay, just put on my desk then. Thank you. Okay, so A represents the final amount that's going to be in your bank after a given amount of time. You'll notice I'm just highlighting the word amount because A is amount. That's how I remember it, right? So the total amount at the end of your investment time. P naught. Hopefully you have heard the word naught from physics. It's just a different way of saying zero or original. So P naught is your initial amount. And again, the way I remember this is by thinking it original. O for original. P naught or P0 is the original amount of money that I'm investing. R represents the rate of yearly investment. This is often given to you as a percent. However, as mathematicians, we know that when we are working with percents, we must calculate them as decimals, not as percents. N represents the number of times your interest gets paid out in a year. So you're not getting 10% every month. You're getting your 10% split over every month. So they take your 10% and they split it into 12 chunks and they reinvest it or recalculate it every month to give you an incrementally higher payback rate. Okay, so the higher the compounding period, the more often they pay you out, typically the more money you're making in the same amount of time. Okay, and lastly, time is the amount of time you're investing in years. This is, by the way, the same formula that you're going to use if you're taking out a loan. It's just now money you owe instead of money you make, but the idea is the same. Okay, for those of us who don't know English very well, we are going to make a list of ways that we can be paid out. What are the compounding periods? I'm going to write this out. Compounding. Oh, man. Oh, fun fact. In Russian, the cursive letter G is their letter D, and my brain cannot, for the life of me, remember which language I'm writing it when I'm writing my D's and G's. So I often will write the letter D. You can see I started writing the letter D instead of the letter G when I was putting it. Anyway, then. Oh, yes, sorry, did I miss that part? I grew up in Russia. Compounding period. That context would have been helpful, right? Yeah, so I grew up learning how to read and write in cursive in both Russian and English. And because there's a lot of overlap with the letters, but for some reason, my brain can differentiate all the letters. I know the English alphabet, and I know that it is different than the Russian alphabet and the Greek alphabet, which is another one I learned, but I cannot forget the G and the D. I cannot figure out which language I'm writing in, and so often you will see a D in place of a G or a G in place of a D when I'm writing, and just that's the reason. Can't do it in my head for some reason. Okay, so we can get paid out annually. Annually. Let's try that again. Annually. Semi-annually. Sorry, my writing is terrible today. I've just done this 3 times and now my brain is like, stop. What else can we do? We can get paid out quarterly. We can get paid out monthly. We can get paid out semi-monthly. We can get paid out weekly, bi-weekly, and the last one is daily. Okay, so all of these words represent our compounding period, which is represented in our formula by the letter N. These are fixed amounts. We don't get to choose these unless you're negotiating the terms of your loan or your investment. If you get paid out annually, how many times is that per year? 1. Semi-annually, 2, then 4, 12, 24, 52, 26, and 365. Now, those of you who will get the opportunity in the near future to negotiate your salary with a future employer, I want to highlight these 2 things. If you are paid monthly or semi-monthly, that means you're getting paid either on the 1st of the month or the 1st and the 15th of the month. This means you're going to get a paycheck 24 times. Whereas if you get paid out bi-weekly, you get 1 more paycheck in a year than you would otherwise. Now, this isn't necessarily saying that you're going to get more money. It means you're going to get more money more consistently. The total amount of money you're going to get is going to be relatively the same, especially if you're on a salary kind of a job, right? It's how often you're getting your paycheck. Now, if you are working hourly and you have the opportunity to do overtime and things like that, then this will make a very big difference because you do have the opportunity to make slightly more money in between the paychecks as well. So just something to consider. If you're looking at money that you are getting, it is always better to be getting it more often, so your compounding period should be bi-weekly. Same with making payments on a loan. A lot of loan companies and loan agreements will offer you to make your loan payments either monthly or semi-monthly, even though they're doing the calculations of interest more often. So if you want to get out of debt quicker, it is always better to pay your debt bi-weekly because you're going to squeeze in an extra payment a year, which annually will cut your loan payments down by years at the end of it, especially if it's something big like a mortgage or a student loan that might be huge. Just something to think about. Okay, so these are set numbers. We're not changing them. We just need to remember the language. Okay, and if you're an English speaker, that's great. And if you're not an English speaker, now you have a chart. Okay. The other thing I want to point out before we move on here is that this formula tells you the total amount in your bank after you are done with the investment. If I were to ask you how much interest you got, how would you do that? How much interest did you gain in your investment? How would you find that? Yeah. You can. It's a little bit simpler than that. Look at all the pieces of information that you know. You know your final amount, you know your initial amount, you know how long you invested it for, at what rate you invested it for. If you put in a bunch of money and you got out a bunch more money, how would you calculate your interest? Final minus initial, right? So this is something to remember, that the A value represents the initial amount you put in plus your interest. There's no explicit formula for it because it's a bit common sense. But I find when we're learning things for the first time, common sense, we need to just write it down. Okay, so when you're looking for interest, final minus initial will give you the difference that you got, right? The other thing I want you to know is when you're putting this into your calculator, how you put it in is going to be very important. The most common mistake is calculator errors in this section. So when we're putting it into your calculator, you are going to be very, very explicit in how you type it in. You're going to take the P0 value times open bracket 1 plus R divide sign N, close the bracket. And then here's where again it gets tricky because all of us have slightly different calculators. We want this to be to the power of open bracket N times T. And if you're using a Texas Instrument calculator, whether it's a graphing one or a scientific one, the exponential button looks like that. It's an up arrow looking thing. However, if you are using some other brand, sometimes it's this symbol and sometimes the symbol looks like this, x to the power y or y to the power x. Or some other variable. It could be a to the power b. So if you have a Casio or I can't remember the other brands, a Sharp, every year somebody comes up to me with a new calculator and I have to find the new button again. But you're looking for something like this, a variable raised to the power of another variable. Or you are looking for an up arrow button. That is going to be your exponential button. Okay, now, alternatively, to save yourself some buttons here, to make life a little bit simpler, you could just simplify what is n times t in that exponent and then do p naught times 1 plus r divide by n to the power of blank, whatever number you get here. That'll save you some margin of error because it's a lot of brackets and a lot of buttons to put into one line, especially if you have a scientific calculator. You might not be able to see your entire equation, and that's where people start getting messed up because they can't see their mistake. So we haven't done anything yet, right? We're just talking here. When we do applications, the math is quite simple. You just need to understand the theory behind it, all the definitions behind it. Okay, we've talked enough. Let's do some math. Find the interest earned if $6,500 is deposited into an account paying 6% compounded monthly for 5 years. For any word problem, I always highlight the key features and I label the pieces of my equation. My P naught is 6,500. My rate is 0.06 because I'm converting it into a decimal. My compounding period N is calculated monthly, so this is a value of 12. And the time of my investment is 5 years. And Mr. Hendricks has a wonderful announcement for us. Hi, sir. Oh, who are you looking for?
Jasmine, where's Jasmine? Jasmine wanted
Oh, she had a something or other. She had to go.
something.
I can't remember what, but it was
Okay.
important.
I will make my way back at another date.
Okay.
Thank you.
Thanks. Bye. Okay, we have all the pieces of our puzzle. We're going to put it into the equation that they gave us at the top. So my investment value is going to be 6,500 times 1 plus 0.06 over 12 to the power of 12 times 5. I'm going to give you guys a head start here while I pull up my graphing calculator. It takes a minute to load. Simplify the exponent first, right? Do 12 times 5. Type it in very carefully. Okay, so I simplified 12 times 5 is 60. Very carefully put it into my calculator. And this tells me that my investment will be worth $8,767. And because we are working with dollars, we will always round to 2 decimals. Even if it's a whole number, you're going to put 00 behind it. Okay? So my investment is now worth $8,767.54. No, 53. Thank you. 53 cents. If you have a scientific calculator, do not forget the in-between multiplication sign and to very carefully put brackets around everything. Okay. Am I done? Is this my final answer? It is not my final answer. What am I missing? The interest. It's asking me not for my total investment. It's asking me for my interest. What am I going to do? Subtract what I started with from what I ended with. And so my final interest amount is going to be 2,000. You're going to have to help me. 2,267.53 cents. Okay, so this is my final minus my initial to find my interest. Your interest basically is how much did your money grow in that time. Okay, I see a few people still struggling with their calculators. Do you need a minute to try that again? Okay, take a minute, try it again. You want to see my calculator? Here you go. Watch your brackets. Make sure you're choosing the right exponential button.
That times 5.
Okay, I'm moving on to example B. In example B, we are going to be asked to work backwards. It says, what is my initial investment? If I want to be a millionaire after 25 years, receiving a rate of 12% compounded quarterly. Okay, this is where I do not know my initial investment. What does this tell me? My final amount should be 1 million. So how many zeros is that? If I'm investing for 25 years, that's my time. My rate is 0.12 and my N value is 4 because it's quarterly. Okay, so let's plug it in. 1 million. Please count your zeros carefully. Equals P naught 1 plus 0.12 over 4 to the power of 4 times 25. So I'm matching the values in my question with the equation given to me at the top of the page. Right? We know how to match stuff. Now, I am looking for the value of my original investment. Do we know how to solve a question like this? Yes. Do you see how these two questions are the same? Just with different numbers, right? So what we want to do is we want to simplify this into one number first to make it look like a question like this. Once we simplify the stuff in the brackets, all we do is take our final investment, divide it by the interest rate growth, and that's going to give us our initial investment, okay? So again, putting this into our calculator very carefully, we are going to have 1 plus 0.12 divided by 4 to the power of 100. Right? I'm simplifying n times t, 4 times 25 to 100, and hitting enter. And my number is a bit ugly, but it's fine, right? We are capable of dealing with ugly numbers. So this is going to be 1 million. Oops, I missed a 1 there. Okay, again, this is going to be where some calculators fall apart. If your calculator remembers the line before and you have the option to use answer as your number, great. If you don't have that option, then when you simplify this on paper, you need to keep 5 decimals in order to have some semblance of accuracy. Okay? Just like how we did with trig. You keep lots of decimals and you only round off your final answer. You don't round off before. Gentlemen, behave. Okay, so now I'm going to take my 1 million, 1, 2, 3, 4, 5, 6 zeros, and divided by, my calculator has the option to give me, use the answer from the line before. And so this is telling me that the initial investment should be $52,032.84. And because we're dealing with word problems, we need to identify what number our final answer is. In this case, it's dollars. Okay, so if you have rounded the number and you typed in 19.218, blah, 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 that's fine. Make sure you are using lots of decimal places. The more decimal places you use, the more accurate your number is going to be. Okay, and again, pay attention to rounding for dollars, so 2 decimal places. All right. We're going to look at a comparison now. What is the better investment? $10,000 for, with 6% compounded quarterly for 10 years, or $10,000 also for 10 years, but now we have 6.25% compounded annually. The quarter here is what we're testing. Is it better to be paid out quarterly or to have an increased quarter percent? That's really the key of this question. So because I'm comparing 2 methods, I'm just going to split my screen here. I'm going to set up the first half of the equation. I'm starting with $10,000. 1 plus 0.06 compounded quarterly for 10 years, or $10,000 . . 10 , 0 , 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, Note the difference here. In the purple highlights, because my n has a value of 1, I don't really need to write it, because anything divided by 1 is the same number. Anything times 1 is the same number. Whereas in the blue highlighted part, I have to have a denominator of 4. That's my n value is quarterly. And I'm multiplying my years by 4 because it's n times t in the exponent, right? Okay, I'm not going to show you how to type this one out. We've done some practice. You tell me, what is the value of option A versus option B? Pay attention to your brackets. Make sure you have a multiply and divide sign in all the right spots. 18,140.18. Yeah, okay. This one will also start with 18,000. What's the rest of this number? 335.36. Okay. So if you are an investment company or an investor, as you will be at one point in your life, and you are debating same number of years, same number of initial investment, it is better to have a higher interest rate than it is to have a higher compounding rate. This is not true if the interest rate is the same, though. If they offered you 6% compounded quarterly versus annually, you go quarterly because you're getting it recalculated more often. But if they're saying you want a higher compounding period or do you want a higher interest rate, your interest rate long-term will outweigh the compounding period. Okay, so higher N is better in this case. This doesn't always, it's not always true because if your interest rate is very different, right, it could swing the other way. It really depends on the investment. But now you have a formula that will tell you exactly which one's better. And fun fact, I actually use this. I was teaching this lesson 5 years ago, 2018. My car blew up. It broke down. I needed a new car. I went to the dealership. I said, okay, I need a new car, blah, blah, blah. And I was going in to buy a used car. And he said, oh, you know what? A new car will be cheaper in the long run. And I was like, okay, tell me why. And so he did essentially this equation. He was telling me, oh, you know, if you buy a used car, your interest rate will be between 6 and 8%. But if you buy a new car, your interest rate is only 1%. And then he did the calculations and I was like, no, that's not right. He goes, yeah, no, it totally is. And this is a guy who's a car salesman, right? He has a computer program where he types in all these numbers and it spits out a payment value and a final how much I would owe at the end, my A value. And he goes, yeah, look, and he shows me his computer. And then I pulled out my phone and I did this right in front of him. And I showed him my phone. I'm like, you're wrong. He goes, no, but the computer. I'm like, your computer is wrong. And he goes, no. I'm like, my friend, I'm a math teacher. Trust me, your computer is wrong. And he would not believe me. And he just would not let it go. He's like, really, a new car is better than a used car. He was right, by the way. In the end, my payments for a new car were lower than my payments for a used car. But at the end of the loan, I have a longer loan with a new car. So at the end of it all, your new car will cost you more than a used car. And so he didn't know the difference. He was like, it's going to be lower payment and it's going to be lower money. I'm like, there's no way you're making less money on a new car than a used car. Like, you're wrong. So anyways, So then he looks back at his computer and he's trying to find his mistake, and he did eventually find it. He did make a mistake on his computer. But it's just so funny because a lot of people will trust their phone and their algorithms. Don't trust it. Technology will lie to you all the time. You should know the math behind it, because at some point there will be a guy or a girl at a bank who's going to sell you promises, and they're going to make a mistake. And you can easily, with your phone in 2 seconds, check their work. Okay. Story time's over. Let's finish this off. Hi. Guys, we're in grade 12. I really don't want to play. Hands to yourself. Please give it back. If it's not your calculator, give it back. And if you need a calculator, there's a basket of calculators behind you. Just give it back. We're not doing this. Okay. Exponential functions in the science world. Okay, so we just did the business world with finances. Now we're going to do the science world with growth and decay models. Many of the things are the same. A is still your final amount. P naught is still your initial amount. My R, though, is going to be the difference from the initial amount. So my R will be 1 plus or minus a percentage. So if you have an increase of 10%, means you are starting with your base population increasing at 10%. So my R is 1 plus 0.10 or 1.110. Or sorry, 1.10, right? If you are decreasing, that means you are subtracting from the initial population. So it's going to be 1 minus 0.10. So your answer for R is 0.9. Okay. Pop quiz, School of Science. What is half-life? Half-life. When we're talking about the decay of something, what's a half-life? What is the change in the rate? 0.5, right? So when we talk about half-life, automatically your R should be 50% because we're cutting it in half. That is what half means. Okay, so keep that in mind as we do the next few questions. Lowercase t represents the unit of time measured that we are choosing. It is a variable that we are going to be using to measure growth or decay. Capital T is the length of the R life, meaning the length of the rate of life. So what is the rate of the half-life? What is the rate of the growth life? This is a fixed number that we do not get to change, and that is capital T. Okay, the other letters are the same. So let's take a look here. The half-life of plutonium-239 is 25,000 years. How much of a given sample will remain at 2,000 years? What do I know? Half-life means R is 0.5. We are reducing it by half. 25,000 is what? What kind of time? Capital T time, right? It's the time of the half-life. This is a given and fixed number. We are measuring the sample after 2,000 years. That is our choice. So this represents small t. It matters absolutely which one is small, which one is big. Because we are choosing to measure it after 2,000 years, we do not get to choose the 25,000 years. The 25,000 is a fact. The half-life is 25,000 years. We don't get to decide that. But we get to decide when we measure the half-life, so the 2000 is the small t, the variable, okay? Now, you will notice here it doesn't give us guys, it's not giving us an initial amount of plutonium. So we are going to assume that we have a sample of 1 unit, 100% pure plutonium, and it's going to decay, and we want to know how much percent is left after 2000 years. Okay, so if, I'm going to make that a star, if P naught not given, then assume it's 1. We're looking at a percentage. If we start with 100% plutonium, how much is left after 2000 years? Now, if it's asking you to find the initial, that's a different question, right? This is asking us for the final amount, but not telling us the initial. So we're going to use percentages here. Okay, so looking at the final amount, we start with 100% or 1. Our rate is 0.5 because it is decaying, half-life. Our exponent is 2000, our chosen value, over 25,000, our given value. Putting this into our calculator very carefully, 0.5 to the power of bracket 2000 divided by 25,000, enter. Gives me 0.946 ... Okay, so basically what this is saying is we are going to be left with 94.6%. So any amount that we start with, if we wait 2000 years to measure it, we are going to be left with 94% of whatever we started with. Okay, now if it told you you have 500 grams of plutonium, how much is left after 2000 years? You're going to take this number and multiply by the 500 grams, and that'll tell you how many grams you have left. Okay. The number of fruit flies increases by 25% every 3 days. If the population of fruit flies was 2000 after 25 days, how many were there initially? What do I know? I know my growth rate is what? How would I write it in my equation as a decimal? Try again.
0.0.
Try again.
1.2.
1.25, because I am increasing by 25%, right? When we increase, it is 1 plus the number. Half-life was 1 minus 50%. If I'm increasing, then it's 1 plus 25%. So R is 1.25. What else do I know? Capital T is what? Try again. Try again. 3. It increases every 3 days. We cannot control that measurement. That is a constant given to us. That is how fast the population is increasing. What else do I know? Lowercase t is 25. I am choosing to measure the population after 25 days. What else do I know? Final amount is 2000. Okay, I'm trying to find what is P naught. So plug and chug. 2000 equals P naught bracket 1.25 bracket to the power of 25 over 3. Please make sure that when you're putting this into your calculator, do not forget brackets around your exponent, okay? So, whoopsie. 1.25 to the power of bracket 25 divided by 3. Enter. 6.4207, blah, blah, blah. 2000 equals P naught times 6.4207 dot, dot, dot. What's my final move? Divide by this number, right? Okay. Tell me what you get. 311.5. Actually, no, give me more decimals. 491 dot, 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 dot. Okay, what are we measuring? Fruit flies. As my final answer, how would I say the initial number of fruit flies? Why 312? Can't have half of a fruit fly. Started with 312 flies. Okay, what if I had 311.12 fruit flies? What would be my initial population? Still 312. If you have a population of something that you cannot cut in half, like a person or an animal, you cannot say it's less than, right? I want you to think of it like this. If you have an average, well, let's say you're in Disney and you're making a roller coaster, and to maximize your revenue, you calculate that the average roller coaster can hold 32.3 people. Do you go under or over? Why under? But maximum gives you 33.3. If you go less than, you're losing revenue. Because you're not accounting for the 0.3 person. Because really, when we do 0.3, this is representing like usually a child, right? Because they don't take up an entire seat. And sometimes some kids sit on the, adult's lap. And so that's the number that kind of varies a lot. So when you're doing populations, if you cannot cut the population of what you're measuring in half, you will round up. Always round up rather than rounding down. So we have slightly more than 311 flies, so therefore our initial population was 312 flies. Okay, how much more intense is an earthquake with magnitude 8.5 compared to one with a magnitude of 6.9? Now, for each increase of 1 unit of magnitude, the Richter scale is a 10-fold increase in intensity, meaning it is a base 10 increment. Very similar to chemistry when we do the pH scale. We can say the pH of an acid is 3 or 4, but what is the difference between how do we compare acidity of something with a pH 3 versus pH 4? How many more times acidic is it? If I tell you that stomach acid is a pH of 2 and a Coca-Cola has a pH of 3, how many more times acidic is your stomach than the Coke? No. It's a base 10. Say it again. How do you know? When we are looking at a base 10, we're talking about this. One earthquake is magnitude 8.5, and the other one is 6.9. When we're comparing acidity on a pH scale, this is 1000, yeah? This is 100. How many more times acidic is stomach than Coke? 10 times, right? Because every unit represents a factor of 10. So if I said I have $8.5 and Alicia has $6.9, how many more dollars do I have than she does? How would you do that? I would subtract, right? And I would say the difference is how many dollars? $1.6. Okay, so when we talk about things that are not base 10, so they're not in exponentials, we can just minus these and say, oh, I know this is 1.6. Now, if I have a base 10, what rules can we use such that these two numbers end up subtracting, knowing that they are exponents? Division, right. So when we're comparing exponential functions, in order to have the numbers we're interested in minusing, we have to think of our exponent laws. So when I'm talking about how much more is 8.5 to 6.9, this is what I'm asking because it is a base 10 system. We refer to the exponent, but in reality, we're talking about magnitudes of 10. So this is representing a magnitude of 10 to the power 1.6 difference, right? Now, chuck this into your calculator. Approximately, how many more times in tenths is one than the other? 39 point something. It's 39 times more intense, which is way more impactful when we're talking about that this way than when we're talking about, oh yeah, it's just a 1.6 difference. Yeah, but if you're standing on the ground, it is 40 times more intense. That's a big number to think about, right? Okay. This letter C applies to chemistry in terms of pH scale, physics and geography in terms of the seismic scales. It applies to many other different things. If you turn your page, your homework is 6 questions. All of them have these common themes in it. You have 15-ish minutes, 10 minutes, just a little over 10. You may work on this if you like. My alternative to you is if you are putting your cell phones away into your backpacks, I can also give you your tests and we can debrief on that, okay?